All right, so now we've done factorization, we have done completing the square. Now we move on to solving simultaneous equations. All right, so at level 2, we used to solve two linear equations. So like equation 1, okay, you'd have two of those and you'd solve for x and y. But now at level 3, we're introducing a quadratic equation where you've got an x squared in one of the equations and you need to solve them. So what we then do is, because we are saying y is equals to 5x minus 2 and y is equals to x squared plus 4x minus 8, then essentially you are taking equation 1 where you're substituting it into equation 2. So everywhere where there's a y, you're going to put in 5x minus 2. So let's do that. So we are saying equation 1 is equals to equation 2. So therefore we have 5x minus 2 is equals to x squared plus 4x minus 8. Okay, or you can say substitute 1 into 2, still the same thing. So now we're going to solve for x. So let's group our like terms together. So we have on this side, I'm moving everything over to the right hand side. So 0 is equals to x squared plus 4x minus 5x minus 8 plus 2. So I'm moving these two terms over to that side. Then I have x squared minus x minus 6. Okay. And then I solve for x. So it's x minus 3 times x plus 2. So therefore x is equals to 3 or x is equals to minus 2. Okay. So now that I have my x values, then I can calculate my y values. So my first y value, where y is equals to 5 times 3 minus 2, which is equals to 13. And the next one, y is equals to 5 times minus 2, which is equals to minus 12. Okay, so therefore I have an ordered pair where my x value is 3 and my y value is 13. And the second one is minus 2 and minus 12. So algebraically, okay, those are my solutions. But what do they mean graphically? So they are saying here, this parabola, okay, and this straight line, they touch at 2 points. So points of intersection. So they touch at 2 points. And what are those 2 points? It's at 3, 13 and at minus 2, minus 12. So you can either solve this algebraically like this, or you can solve it graphically where you draw the graphs to scale and you're able to pick up where do they intersect. Right, so here is another example, okay? So here we have the first equation, all right, and the second equation. So from the first equation, you're going to make y the subject of the formula. So 2x minus 1 is equals to y, okay? So that becomes equation 3. So as you would with any other simultaneous equation, so we substitute 3 into 2, okay? So where there's a y, you're going to substitute it with 2x minus 1. So let's do it. So it's x squared minus 2x times 2x minus 1 plus 2x minus 2x minus 1 squared, and that's equals to 0. Okay, so let's work it out. X squared minus 4x squared plus 2x plus 2x minus, what's in the bracket? It's 4x squared minus 4x plus 1. Okay, that's equals to 0. So now I'm grouping my like terms together. So I have x squared minus 4x squared minus 4x squared. So this gives me minus 7x squared. Okay, then I group my x's. Okay, so it's 2x plus 2x, which is 4x. This is a negative, and a negative is a positive. So plus 4x. Then I am left with plus 4x. And then I'm left with minus 1. Okay, so that's equals to 0. Okay, if I divide by a negative number, by a negative 1, then I have 7x squared minus 4x plus 1 is equals to 0. So seeing that here, when we get here, we are not able to factorize, then we are also within our rights to use the quadratic formula. Okay, so what is the quadratic formula? It's x is equals to minus b plus or minus the square root of b squared minus 4ac, okay, all over 2a. Okay, so for this example here, my b is minus 4. So it's minus 4 plus or minus, okay, minus 4 squared minus 4 times 7 times 1, okay, so all over 2 times 7. So we get x is equals to, so let's use, oh, that's not very clear now, is it? Okay, so let me just repeat that quickly. All right, so the quadratic formula is x is equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so now remember, this here represents the a value, this here represents the b value, and this here represents the c value. Okay, so now if I was to substitute those values into my formula, then I have minus 4 okay, I have minus 4 plus or minus 4 squared minus 4 times 7 times 1, okay, all over 2 times 7. I've actually been trying to see where I went wrong, okay? And I see that I went wrong over here because it's 2x plus 2x plus 4x. So this is plus 8x. No wonder it didn't make sense. Okay. So plus 8x, so this becomes minus 8x. Okay, so this you can then factorize. when you factorize it, it's 7x minus 1 times x minus 1 is equals to 0. So therefore, x is equals to 1 over 7. Okay, and when x is equals to 1 over 7, y is equals to 2x minus 1. So 2 times 1 over 7 minus 1. Okay, so that's 2 over 7 minus 7 over 7. So y is equals to minus 5 over 7. Or x is equals to 1. And when x is equals to 1, then y is equals to 2 times 1 minus 1. So therefore, y is equals to 1. Okay, the next one is when we're solving it graphically. So you'll be given two functions. So we're given an f of x and a g of x. And we are then asked to solve for x and y where the graphs meet. So the points of intersection. Okay, so let's start off with the straight line. So using the intercept method, so the y-intercept on the straight line is you make x to be equals to 0. So therefore y, okay, so y is equals to minus 2 times 0 plus 6, which is 6. So my y-intercept is 0, 6. Then to find my x-intercept, okay, I set my y to be equals to 0, and I solve for x. So minus 6 is equals to minus 2x. Therefore, 3 is equals to x. So my x-intercept is 3, 0. Okay, then I should be able to draw my graph. This one, g of x, my y-intercept, okay, where I put in 0, where there's an x, okay, 2 times 0 plus 3, and my final answer is 3. So therefore, my y-intercept is 0, 3. Then for my x-intercept, I set y to be equals to 0, okay, minus x squared plus 2x plus 3. So then I must solve for x. So if I divide by negative 1, I have x squared minus 2x minus 3. So I'm able to factorize that. So it's x minus 3 times x plus 1. So therefore, x is equals to 3, or x is equals to minus 1. So my x-intercepts are 3, 0, and minus 1, 0. But also with the parabola, we also then need to find the turning point, all right? And how do I find the turning point? To find the turning point, okay, I use this formula, x is equals to minus b over 2a, all right? And minus b, so my b value here is 2, okay? So minus 2 over 2 into minus 1, because a is minus 1. So my final answer here is 1. So my turning point is where x is equals to 1. Then I must find the corresponding y value. So in my equation, where there's an x, I must put in 1, okay, so that I can find my y value for my turning point. So this tells me it's 2 minus 1, which is 1, plus 3 is equals to 4. So my turning point is at 1, 4. So now I can actually then draw my graph. Okay, so let's draw it. Okay, so let's do 2, 4, 6. That's y, and then here we'll use ones. We'll come to ones. 1, 2, 3, 4, So 1, 2, 3, 4. Okay, so let's start with the straight line first. So I said my y-intercept was here at 6 and my x-intercept was at 3. So I join the 2 points, I use a ruler, and my line goes something like that. Okay, and then with my parabola, all right, I mark off, there's my one x-intercept, my other one is also here, okay, and then my turning point is at 1, 4. So that's at this point over here, all right? Now, my A is negative, which means now that my graph is a maximum graph. It's a sad-looking graph, okay? And here we had to note the y-intercept. So the y-intercept is here at 3. So then this tells me that my graph cuts the y-axis at 3 and the x-axis at -1. And at the turning point, then it goes from there down there to 3. So where are my points of intersection? My points of intersection are here and also there. So those are the 2 points where my graphs meet. So this tells me now that my solution is going to be, okay, my solution is going to be where x is 1 and y is 4. And also at this point here, where x is 3 and y is 0. So those 2 points are my points of intersection.